In this video, I will explain the basic concepts and fundamentals of Cisco access control lists. I prepared this video exclusively for beginners. If you have no prior knowledge of ACLs and don't know where to start, this video is for you. This video covers everything that you should know to work with ACLs. Access lists work on routers. Routers connect different networks. When a router receives a data packet on its interface, it reads the destination address of the packet and forwards the packet from the interface that is connected to the destination address. This process is known as routing. Routers follow this procedure for all packets. By default, routers do not differentiate between genuine packets and fake packets. Any host that knows the correct destination address can send packets through the router. If an adversary knows the correct destination address, the adversary can also send packets through the router. If you want to allow or deny only certain packets, you have to define the criteria and actions for the packets. Once the criteria and actions are defined and applied, the router processes all packets through the defined criteria and actions. To define the criteria and actions, routers support ACLs. An ACL stands for Access Control List. It is a list of statements. Each statement in ACL is written on a separate line. ACL statements are also called ACL entries. In other words, each line of the ACL is a statement or an entry. An ACL statement consists of criteria and actions. The criteria define the pattern to be matched and the actions define the functions that must be performed when the pattern is matched. An access list is a set of additional commands or instructions that you can instruct a router to perform before forwarding IP packets. Let's take an example to understand how Cisco access lists work. In a network, 4 LAN segments are connected through a router. These segments are students, teachers, staff, and administrators. These segments respectively belong to students, teachers, office staff, and management team. As far as connectivity is concerned, this network is good. All LAN segments can access each other without any issues. The main drawback of this network is security. This network has no security policy. Anyone can access any resource of the network. A student can access the teacher's computer. A teacher can access the principal's computer. This free flow of access makes this network useless. This network will be useful only if it allows only authorized users to access permitted resources. To block unauthorized access, the administrator can configure access lists on the router. Once the access lists are configured, the router will forward only authorized packets. When creating an access list entry, you should keep 3 main factors in mind. These factors are location, direction, and order. Let's discuss these factors in detail. Location. Access lists are applied to interfaces. For example, if a router has 2 interfaces, you can apply different access lists to both interfaces. An interface can only use its ACLs to filter the traffic that passes through it. It cannot use the ACLs of the other interface. If you apply an ACL to an interface that does not process targeted traffic, that ACL will not work. An ACL acts as a sieve. Just as a sieve uses its mesh to filter out liquid or small particles from a mixture, an ACL uses its statements to filter out the desired packets. A sieve can filter the mixture only when you pass the mixture through it. Similarly, an ACL can filter traffic only if traffic is processed through it. Let's take an example to understand how location affects ACL. In this network, 3 segments are connected through the router. Without any ACL, all segments can access each other. Now, the administrator wants to prevent the staff segment from accessing the server segment. For this, he created an ACL and applied it to the F0/1 interface. Will this ACL work? No, instead of blocking the staff segment, this ACL will block the administrator's segment. The F0/1 interface connects the administrator's segment to the server segment. To access the server segment, the traffic of the staff segment neither enters nor exits from the F0/1 interface. Since the traffic of the staff segment does not interact with the F0/1 interface, the ACL applied to the F0/1 interface does not affect it. When implementing an ACL on an interface, make sure that the interface interacts with the targeted traffic. If the targeted traffic does not pass through it, the ACL will not work. Direction. When a router receives a packet on its interface, it reads the destination address of the packet and forwards the packet from the interface that is connected to the destination address. We can divide this process into 3 phases. These phases are entry, process, and exit. In the first phase, the packet enters the router. In the second phase, the router processes the packet. In the third phase, the packet exits the router. We can apply an ACL before the first phase and the third phase. We can't apply an ACL before and after the second phase. If we apply the ACL before the first phase, the router will process the incoming packets through the ACL. If we apply the ACL before the third phase, the router will process the outgoing packets through the ACL. Inbound and outbound ACLs. If you use an ACL to filter incoming traffic, it is called an inbound ACL. If you use an ACL to filter outgoing traffic, it is called an outbound ACL. An inbound ACL cannot filter the outgoing traffic, whereas an outbound ACL cannot filter the incoming traffic. Let's take our example back to understand the effect of the direction on the ACL. To prevent the staff segment from accessing the server segment, the administrator applied the outbound ACL to the F0/0 interface. Although the administrator has applied the ACL to the F0/0 interface, yet the staff segment can access the server. Can you guess what's wrong with this implementation? The F0/0 interface is the default gateway of the staff segment. It receives traffic from the staff segment and forwards it to the server segment. The F0/0 interface is the entry point of traffic. The administrator applied the outbound ACL to filter the incoming traffic. The traffic of the staff segment enters the F0/0 interface. It does not exit the F0/0 interface. An outbound ACL can't filter the incoming traffic. To filter incoming traffic, the administrator has to apply an inbound ACL to the F0/0 interface. Once an inbound ACL is implemented, the interface will filter each incoming packet through it. The interface will permit only the authorized packets. Order. Once the access list is implemented, the router processes each packet through the access list. For each packet, the router checks each entry in the access list from top to bottom until a match is found. Once a match is found, the router executes the corresponding action. It does not check the remaining entries for that packet. If an access list has multiple entries for the same packet, the router will only execute the action of the first entry from the top. For example, if you apply the following ACL on a router, the router will never stop a white car, even if there is an entry in the ACL that blocks the white car. If you want to allow only some hosts from a network, you should add the allow statements first in the ACL. If you add an allow statement below the deny statement of the same criteria, the allow statement will never execute. Let's understand it through our example. The administrator wants to allow only the host 10.0.0.10/8 from the 10.0.0.0/8 network to access the server segment. For this, he created an ACL and applied it to the F0/0 interface in the inbound direction. Afterward, all traffic from the staff section has blocked. Even the host 10.0.0.10/8 has an allowed entry, still the host can't access the server segment. Can you guess why this ACL is not working? When the packets from the host 10.0.0.10 enter the F0/0 interface, the interface checks the applied ACL. The first statement of the ACL says deny all incoming traffic. Since this criterion matches all incoming packets, the interface never checks the next statement for any incoming packet. It always executes the action of the first statement. Since the action of the first statement is the deny all incoming packets are denied. To fix this issue, the administrator needs to put the allow statement before the deny statement. The correct ACL is the following. Allow 10.0.0.10/8 deny all. Now, when packets from the host 10.0.0.10/8 enter the F0/0 interface, the interface will allow them. But if it receives packets from other hosts, it will discard them. Let's understand why this will happen. When a packet enters the interface checks the ACL. The first statement of the ACL is for the host 10.0.0.10/8. The interface will check the source address of the packet. If the source address of the packet is 10.0.0.10/8, the interface will execute the action of the first statement. The action of the first statement is allow. Because of this, the packet will be allowed. If the source address of the packet is not 10.0.0.10/8, the interface will check the next statement. The next statement is deny all. This will match all incoming packets. The action of the second statement is deny all. Because of this, the packet will be discarded. Thus, apart from the packets of the host 10.0.0.10/8, all incoming packets will be discarded. Now, we have discussed and learned how the three main factors of the ACL work. Let's take our example back to understand how these factors affect the ACL implementation. In our example network, all LAN segments can access all LAN segments. To block students from accessing resources outside the student's segment, the administrator created an access list and applied it to the F0/0 interface of the router. The ACL has the following entry. If a packet has the source address from the network address 10.0.0.08, then discard the packet. Since all packets generated from the student's segment have source addresses from the 10.0.0.0/8 network, they will be blocked as soon as they enter the F0/0 interface. After this ACL, users from the student segment will not be able to access outside resources. But they will be able to access all resources available in the student segment. To understand how the location affects the ACL, let's suppose the administrator applied the above ACL to the F0/1 interface. Now, this ACL is useless. This ACL instructs the router to block a packet if it arrives from the 10.0.0.0/8 network. A packet from the 10.0.0.0/8 will never enter from the F0/1 interface. The F0/1 interface is the default gateway of the teacher's segment. Since the network address of the teacher's segment is 20.0.0.0/8, all packets entering F0/1 will have a source address from the network 20.0.0.0/8. This example shows how the correct location of the ACL is important. An ACL must be implemented on the interface that interacts with targeted traffic. Now suppose, instead of using the source address in the ACL entry, the administrator mistakenly used the destination address. The modified ACL says, if the destination address of a packet is from the network 10.0.0.0/8, discard the packet. The administrator applied this ACL to the F0/0 interface of the router. Will this ACL work? No, this ACL will not work. This ACL instructs the router to block the packets that are going to the network 10.0.0.0/8, not to the packets that are coming from the network 10.0.0.0/8. If you apply this ACL to the F0/0, the student segment will be able to access all three segments, but they will not be able to access the student segment. Thus, an ACL must be implemented in the correct direction to filter the targeted traffic. As mentioned earlier, for each packet, the router checks ACL entries from top to bottom until a match is found. Once a match is found, it does not check the remaining entries for that packet. Let's understand this factor through the example. The administrator wants to allow a user from the teacher's segment to access the printer available in the staff segment. The IP address of the allowed user is 20.0.0.3/8. Apart from the allowed user, all remaining users must not be able to access the staff segment. For this, the administrator created the following ACL and applied it to the F0/1 interface of the router. Drop the packet if its source address belongs to the network 20.0.0.0/8. Allow the packet if its source address is 20.0.0.3/8. Will this ACL work? No, this ACL will block all outgoing traffic from the teacher's segment. When a packet originated from the host 20.0.0.3/8 reaches the router checks the entries of the applied ACL until a match is found. The first line of the ACL says drop the packet if its source address belongs to the network 20.0.0.0/8. Since the IP address 20.0.0.3/8 belongs to the network 20.0.0.0/8, the statement becomes true. The router executes the action that is associated with the first statement. Since the action of the first statement is the drop, the router drops the packet. Even the second line of the ACL allows the host 20.0.0.3/8, but it will never be read and executed by the router. The correct order to allow the host 20.0.0.3/8 will be the following. Allow the packet if its source address is 20.0.0.3/8. Drop the packet if its source address belongs to the network 20.0.0.0/8. Now, this ACL will allow all packets originating from host 20.0.0.3/8, but it will block all packets originating from other hosts in the network 20.0.0.0/8. Thus, The correct sequence of the statements in the ACL is important. There are mainly two types of access control lists, standard and extended. You can further classify these types into two subtypes, numbered and named. A standard access list can be either a numbered standard list or a named standard access list. Similarly, you can have a numbered extended access list or a named extended list. Beginning with iOS version 12.3, Cisco introduced a new feature to edit existing ACLs. This feature is called the sequence editing feature. You can further classify ACLs based on this feature. Let's discuss the properties, characteristics, and functions of ACL types and understand how each type differs from the others. Standard access lists. Standard access lists are easy to configure. But they support limited options and entries. In a standard access list entry, you can use only the source address to define the criteria. Apart from the source address, you can't use any other option. Standard access lists work on an all or none formula. They will either allow or block all traffic from the source host. You cannot allow or deny only certain types of traffic from the source host. Since standard access lists work with all traffic originating from a host, they are applied closer to the destination. Extended access lists. Extended access lists are complex. But they support many options and entries. In an extended access list entry, you can use a source address, a destination address, protocol, traffic type, application, and port to define the criteria. Extended access lists allow you to target a specific type of traffic. You can allow a certain type of traffic while blocking the remaining traffic, or you can block a specific type of traffic while allowing the remaining traffic. Since extended access lists work with a specific type of traffic, they are applied closer to the source. Numbered and named ACLs. Routers support multiple ACLs. You can create as many ACLs as you want. To differentiate between ACLs, routers use a unique number and name for each ACL. You may consider these numbers or names as identification numbers or names. When creating an ACL, you must specify an identification number or name for the ACL. Since the router uses this number to identify the ACL, you cannot choose a random number for the ACL. You have to choose a number from a predefined range. Routers reserve the following number ranges for standard access lists and extended access lists. Numbers are a bit difficult to remember. They also do not provide any descriptive meaning. If you have multiple ACLs, it becomes very difficult to remember which ACL is doing what. To make ACLs management easier, routers also support names for ACLs. It means you can also use descriptive names for ACLs instead of predefined numbers. No matter whether you use a name or a number for the ACL functions the same way. As far as functionality is concerned, named ACLs and numbered ACLs are the same. The main advantage of a named ACL over a numbered ACL is that a named ACL is easier to manage and remember than a numbered ACL. Let's take an example. You check the configuration of a router and find the following ACLs. To figure out what these ACLs are doing, you have to check the entries of each ACL. Now, suppose you read the configuration of another router and find the following ACLs. By looking at these ACLs, you can get an idea of what each ACL is doing. For example, by looking at the name blocking students, you can guess that this ACL would be blocking traffic from the students segment. By using a descriptive name, such as block external users, a network administrator can easily determine the purpose of the ACL. This feature is especially helpful in large networks, where a router may have multiple ACLs with hundreds of statements. Advanced Sequence Editing ACLs. Advanced sequence editing is a new feature. Before this feature, editing or updating ACL entries was not possible. To edit an ACL entry, you had to recreate the entire ACL. This feature allows an administrator to change, update, or delete a single entry from an ACL. This feature was added later to Cisco iOS. All new iOS versions include this feature. If the iOS includes this feature, you can use this feature to edit both types of ACL. ACLs are not simple. They are one of the most complex features of the router. They only work when they are applied properly. An incorrectly applied ACL can lead to the opposite or strange results. For example, if you have created an ACL to block a certain type of traffic but have implemented it on an interface that does not interact with that traffic, then this ACL will not work. To get the desired results from ACLs, you need to build and implement them properly. There are some basic principles and rules for creating and implementing an ACL. Understanding these rules and principles will help you create and enforce ACLs more effectively. ACLs are implemented in 2 steps, creating and activating. In the first step, you create an ACL. In the second step, you apply it to an interface. Until you apply it to an interface, it remains in an inactive state. An access list does nothing in its inactive state. To activate an ACL, you have to apply it to an interface. You can apply an ACL in 2 directions, inbound and outbound. If you apply the ACL in the inbound direction, it will filter the incoming traffic. If you apply the ACL in the outbound direction, it will filter the outgoing traffic. You can apply only one ACL per interface per protocol per direction. For example, you can apply only one ACL to filter incoming IP traffic on an interface. When applying an ACL to an interface, you have to specify the direction in which you want to filter the traffic. Once an ACL is applied to an interface, the interface processes all packets through the ACL. For each packet, it checks all ACL entries from top to bottom until it finds a match. If it finds a match between the packet and the entry, it executes the action defined in the entry. If it does not find the match, it checks the next entry. If the next entry matches the packet, the interface executes the action defined in the next entry. If the next entry does not match the packet, the interface will keep checking entries until it finds a match. Let's understand this process through this example. It is a red packet. It will always be allowed. The router will never check the second line for red packets. The router will check the second line only if the packet is not red. It is a blue packet. Since it is not a red packet, the router checks the second line of the ACL. The second line discards the blue packet. It is a brown packet. Since it is not a red packet, the router checks the second line. The second line matches only blue packets. Since the packet cannot be processed by the second line, the router checks the third line. The third line allows brown packets. Since the action for brown packets is allowed, the router allows it. It is an orange packet. Since it is not a red, blue, or brown packet, it will not be processed by the first, second and third line. The fourth line of the ACL discards all packets. Because of this line, all packets they are not processed by the first, second, and third lines will be discarded. Once the interface finds a match for the packet, it does not check the remaining entries for the packet. For example, if you have 2 entries, one denying a host and one permitting the same host, the router will execute the action of the entry that appears first in the ACL. It will never read the second entry for the same host. Since the order of entries is important, you should always place the most significant entries at the top of the list and the least significant entries at the bottom of the list. This arrangement will improve the router's performance because most of the time a match will be available at the top of the list, and once a match is found, the router will not check the remaining entries. If a router goes through the entire list and does not find a match in the ACL entries for a packet, the router drops the packet. This aspect is known as implicit deny. Implicit deny is an invisible deny-all statement at the end of every ACL that drops all traffic that does not match any of the preceding statements in the ACL. Because of the implicit deny, every ACL should have at least one permit statement, otherwise, an ACL with only deny statements will drop all traffic. Let's take an example. A segment 10.0.0.0/8 is connected to the F0/0 interface. You want to block only the host 10.0.0.10/8 from this segment. Since you want to block only one host, you created an ACL with a single entry deny 10.0.0.10 and applied it to the F0/0 interface in the inbound direction. Can you guess what will happen in this scenario? This ACL will block all incoming traffic on the F0/0 interface. Let us understand why this would happen. If the packet arrives from the host 10.0.0.10, the deny statement will block the packet. If the packet arrives from the other host, the criteria of the first statement will not match, and the interface will check the next statement to match the packet. Since there is no next statement, the interface will execute the implicit deny statement. The implicit deny statement blocks all packets. This way, all incoming packets will be blocked. To fix this problem, you have to add one more entry just after the first entry. In this entry, you need to write an allow statement for the network 10.0.0.0. After this change, the ACL will block only the host 10.0.0.10 while allowing all reaming hosts from the segment. A new entry is always placed at the bottom of the list. Once you have added an entry, you cannot edit, modify or delete it. If you want to change an entry, you have to delete the existing list and recreate the entire list. Since modification is not allowed, you should create ACL entries on a text editor. After creating them on a text editor, you can copy them to the router. To edit or remove an entry from the existing ACL, copy all entries into a text editor, modify the entries, and copy the updated entries back to the router. This restriction does not apply to routers that support a feature called sequence editing. If a router supports the sequence editing, you can edit or remove a single entry from the existing ACL. An access list filters the traffic passing through the router. It does not filter the traffic that originated from the router. A standard access list can only filter traffic based on the source address. An extended access list can filter traffic based on specific addresses and protocols. We can apply the same ACL to multiple interfaces. We can enable the same ACL twice on the same interface in separate directions, inbound and outbound. We cannot enable the same ACL twice on the same interface in the same direction. An empty ACL will permit all traffic. Implicit deny condition will work only if ACL has at least one user-defined condition. That's all for this video. In this video, we learned about the basic concepts and fundamentals of Cisco access control lists. If you have comments, suggestions, or feedback related to this video, please share them in the comment section given below.